உங்களுக்கு தெரியுதா? Okay. Configuring basic integrated ISIs. We have already done a lab, so this chapter must be easy for you. Integrating ISIs requires net address. In the previous chapters, we saw there is something called CLNS address or net address. All right. In the net address, what all we see? We see area, we see system ID, we see end selector. Even when integrated ISIS is used for IP routing only, the routers still establish CLNS adjacency. Do you remember when we did a lab? I was typing the command show CLNS neighbor. You see, though it is an ISIS routing protocol for IP, still the adjacency is using CLNS at the background. That is why the command is show CLNS neighbor. You can also type show ISIS neighbor. Both will work, but output will be slightly different. And use CLNS package, fine. Now we'll go and verify these things after finishing this chapter. If I jump now to lab for verifying this, then it will take time. Let's finish this. OSI area routing, building an OSI forwarding database routing table. OSI forwarding database. Routing table in another word. When databases are synchronized, Dijkstra's algorithm is run on an LSTB to calculate SPF3. Same like what we saw in OSPF. Here ISIS also uses SPF, Dijkstra's algorithm, to run on the LSTB, linked state database, to pick one best path for every destination. The shortest path to the destination is the path with the lowest metric. How metric is calculated? By adding the cost on the links in between the source and the destination. Each link has got a default cost of 10. I hope you remember that. Each link has got the fixed cost 10. Can we change the metric? Can we change the cost? Okay, yes, we can change the cost. We'll do those things in our following labs in ISIS. Now, separate route calculations are made for L1 and L2 router. On this router L1, L2. Now, you see, I told you in the previous class there is a separate database, one for L1, another for L2. So the calculation is also separate now. For L1, there is a separate route calculation. For L2, there is a separate calculation. If you remember in the previous class, we saw that area ID is used to find the route, to find the best path in L2. Whereas in L1, to find the best path, system ID is used. Best paths are placed in the OSI forwarding database, which is nothing but a routing table. Building an IP routing table. Partial route calculation is run to calculate IP reachability, because IP and end system ES are represented by leaf object. Oh, don't worry about this end system. Let's go to the next one. Best paths are placed in the IP routing table forwarding. IP preferential rules. They appear as L1 or L2 IP route. So if the routes are learned from same area, it's going to show as L1. If routes come from another area, then it is going to be L2 mentioned in the routing table. Do you remember the routing table? of ISIS? Have you seen that? Did you see L1, L2 mentioned in the routing table before when we did the lab? You remember or you don't remember? Okay. All right. So what is the configuration? First of all, we need to get into the router ISIS mode, and then we need to provide the net ID. What does net ID stands for? Network entity title. You see, first you decide what net ID you are going to give, you plan for it, and then you go under router ISIS that enables ISIS, and then optionally you can give process ID. See, in OSPF, if you don't give process ID, you cannot enter into OSPF. You need to say router OSPF 10 or 1, something like that. But in ISIS, you can straight away say router ISIS enter. And then configure the net. After that, you don't have a network command in in all other protocol, including BGP. We use net command, network 1000 with wildcard mask. We used to type in EIGR. Even in OSPF, we have network command, but in ISIS, we need to go straight to the interface. We go to the interface and we say IP router ISIS. Right? Now, step 1. See, here are the 4 steps. Now we are going to see in detail those 4 steps. First, you need to define the area and address. Area determines the net prefix assigned to support 2 level of hierarchy. So you need to provide the area portion and then addressing. IP plan to support summarization. CLNS prefix denotes an area. System ID must be unique. So what really it means is you need to decide what all interfaces that you are going to advertise in ISIS. That we go under the interface and configure. And on the network entity title, these are the 2 things. One is area and then the system ID. The system ID should be unique on each router. So this is how we do. So this is just a planning. Step 1 is just a planning, and this is the very first actual step. We go to the global mode and we say router ISIS. This process ID, see, name for a process. Because it is mentioned as the area tag, don't think that you need to holistically give only the area ID. It's just a process ID, and that is also an optional one. When routing of CLNS packet is also needed, use the CLNS routing command. Anyway, we don't have CLNS, don't worry about it. Next is you go in, after you go inside the ISIS, you say network, net, and then you type network entity title. What is network entity title? Area ID, system ID, and then selector. All right. So then we go under the interface. We call the ISIS, IP router ISIS. If you would have given area tag in the previous screen, then you put the same area tag. Remember, this is in the global mode, step 3, global router mode. After you finish providing the network entity title, you do this under interface. Go to the interface and you call the ISIS. It's under the interface, like this. See, we begin from here, router ISIS. You see, there is no process ID. It's an optional one. Net 49 is private. This is area 1. And 0, 0, 0, 0, 0, 0, up to this 2. The 6 byte is system ID. This is end select. After this, you go to interfaces where you want to run ISIs, call by typing IP route ISIs, IP route ISIs. Now, when you do this, yes. See, 49, if you give or you don't give, it is okay. See, initially, on those days, they did not have a clear picture how the internet world will become. So they thought that this ISIS is going to be a worldwide protocol. But we don't have ISIS now as a worldwide. We have BGP. BGP is the one which is connecting the autonomous systems. ISIS is not the one which is connecting now. But that clarity was not there on those days. So they said, when you put 49 and start, it means private network ISIS. Any other number, it's public ISIS. But this recommendation has gone useless because we don't really use ISIS between organization, between autonomous system after BGP. After BGP has come, we don't use ISIS. We use ISIS as IGP only. ISIS is an IGP protocol. It is not an EGP protocol. Question, please. You can ask question. All right. So when you don't mention L1 or L2, it is both L1 and L2. But if you wish to say only L1 or only L2, you need to go under router ISIS mode and then use the keyword IS type. Use the keyword IS type and then say L1, level 1 or level 2. You have to mention this. Okay? You have to mention level 1 or level 2. The default is level 1 and 2. In case if you have already said level 2 only, you can use this command to come back to L1, L2. That's why you have this. Though by default, this is default. Why we need this? So that if you have gone to level 1 only or level 2 only, you can put this command to come back to level 1 and 2. You can also configure this level 1 or level 2 or level 1 and level 2 under the interface level, but the command is not the same. You see, here the command is ISIS circuit type, whereas in the router mode, it is ISIS type. This is globally the entire router you switch to L1, whereas this command is only that interface is L1 or L2. The command is ISIS circuit type. The previous one is simply IS, not ISIS. This is IS type, intermediate system type. Whereas this one is IS circuit type. Again, the interface is also by default L1 and L2. You know that L1, L2, L1/2. This is where the metric story starts. We all know that the default metric on any interface is 10. You can change the metric by typing this command is metric and then the metric number. You can give number between 1 to 63 only by default. But by changing it to wide metric, you can have more, which we saw in the previous chapters. Maybe it may come next again. So by default, you will have an option to say under the interface only from 1 to 63. You can also set in the global router mode by typing metric default value. You can also specifically say only for L1 this is metric, for L2 this is metric. So when you don't mention level 1 or level 2, it is for both. I think before we go on to before we read this page, I would like to talk more about metric by taking you to the previous chapter. This is very important. By default, under the interface, only 6 bit is given for metric. That is why you saw 64 there. You see here? Sorry. See, 1 to 63. The reason is 2 to the power of 6. That's the maximum you can go because there is only 6 bit. But when you go under ISIS and make a change as wide metric, there's a command called metric style wide. Let me try showing you that command. Okay, it may come in the next chapter. But there is a command called metric style wide. When you change to metric style wide, then per interface, you can have metric of very big number up to 24 bit. 2 to the power of 24 is a very big number, more than a million. And the path metric by default is only 10 bit. Path metric. See, path metric is sum of this metric and this metric, not just the one interface. All interface in the path, right from R1 to R3. By default for path metric, it is only 10 bit. But when you said wide metric, not only the interface bit is from 6 to 24, even the path metric is also increased from 10 to 32 bit. Now let us go back to the chapter. So you can change the metric, but without changing the metric style, if you try giving now 65, it won't accept. You see, it says by default only 6 bit. You can go only maximum this much. If you want to give any number more than this, then you have to first change the metric style to wide, which may come in the next chapter, but I'm going to show you the lab soon after this chapter gets over today. And the metric default value, you can also set per the level base. Level 1, if you want to give one metric, and for level 2 different metric, you can do that. This is for all interface. The previous above one is for per interface. Okay. Here, this must not be a new one for you because we have done a lab already. But just let's go through it. Right? You see here, this router is totally inside area 1. So you can make it as L1 only by typing this command. This is for router 1. You say router ISIs net 49 area 1. This is for router 1 system ID and selector. Then you go to this interface F00, call ISIs by saying IP router ISIs. And then you see this is globally you have changed as L1. And this is interface level you have changed as L1. You see, you don't need to do this. Either you do this or you do this. You got only one interface. Why you need to do again globally when you can do it under the interface? Or why you do at the interface level when you have already done globally? This is just they're showing you the difference, command difference, that's all. But in the real world, you don't need to do 2 times global again under the interface. Okay. Now, if you see this router 2 is talking to another area via serial interface. It is also talking to local area member via F00. So here, if you see here, here we enable ISIS. We give a system ID uniquely. Area ID is same, so it is going to route using system ID. And we go F00. We call ISIS, and here we do under interface level. That is really good, because on this link, on this interface you want L1, whereas on the other link you want only L2. So you don't need to do globally like this. On R1 we did globally. In R2 you don't do globally. Why? Because you don't have the same policy on all interface. This interface is L1. You put this command. ISIS circuit type level 1. And this serial interface is L2 only. So you say what? ISIS circuit type L2 only. And then metric, optionally you can set what is the default metric 10, but here they are making it as 35. And you got only L2, no? So you have to mention, is it only for L2 or both? In this example, they do it only for L2. Which means on fast Ethernet, you will have default metric of 10 only. Any question on this? Okay. Now, like OSPF, you can also summarize in ISIS. But you remember in OSPF, we have 2 different type of summarization. One is ABR summarization, which we do it on ABR. The command was like area ID, range command. That is ABR summarization. ASBR summarization we used to do on the ASBR router. And there also we used the same command. This command is same like ASBR summarization. Example, you see, you go under the router and you say summary address, summarize like this. And you say for both level 1 and level 2. If you want only for L2, you can say only for L2. Okay, that's summarization. Easy, no? Summary address and the way that you want to summarize, you type under the router mode. Some verification commands, we know this protocol command we use for all routing protocols. Show IP protocol we not only use for ISIS. A router runs routing protocol. So if you type show IP protocol, it shows all the routing protocol that you have enabled. In our case, it is only ISIS. The administrative distance of ISIS is what? 115. See ISIS without any process ID, it is enabled. ISIS also supports 4 equal cost path. Right now, ISI is running on this 3 interface. I want to ask you a question because I have covered this thing in the previous 2 class before. What multicast address ISIS uses? Can you answer? What multicast address ISIS uses? No idea? There is no layer 3 multicast address. The reason is this is not a protocol that works in layer 3. ISIS works in layer 2. So you don't have a multicast address of layer 3. There is a layer 2 multicast address, and really no need to worry about it. It's layer 2. There is no fixed layer 3 multicast address for ISIS. There's no address like such. 224 address. No, we don't have. When we do the lab, I'll sniff and show you the layer 2 multicast address. How to identify whether it is a multicast address or not. You will have a number 5E in the middle. Any address, the MAC address, any MAC address which has got 5 elephant, 5E, it is a multicast layer 2 address. Okay, see, when I type show IP route ISIS, I can see that the route 2 has got a network called 103030 learned via L2 adjacency, means coming from another area. Whereas 101010 is from the same area. This is how the routing table looks like. All right, these are all the few verification commands that you should know to troubleshoot. Show CLNS, show CLNS, in case if you use tag. If you use tag and many ISIs, not just one ISIs, many ISIs, then you can say show me for ISIS1 or ISIS2 by typing this command, show CLNS1 protocol. You don't need to do if you don't have that. Next is show CLNS interfaces will show you the number of interfaces that are running ISIs. Show CLNS by area means, if this is not actually area, it's process ID, neighbors. It will show you all the neighbors with which ISIS has formed neighbor. You can also use detail command to show more information about the neighbor. When we do the lab, I'll use this command. See, all this command, you see, all have got CLNS. It's not showing IS, it is not ISIS. But there are some commands which you can use ISIS also in the place. Say, for example, show ISIS interfaces. Both CLNS and ISIS you can have in this place, like this. You see? Show ISIS route. So in the routing table, displays ISIS L1 routing table. Show CLNS route will show you again display ISIS routing table. This is area wise. This is within area L1. Show ISIS database is to see LSDB. Same like we used to type show IP OSPF. See, if you notice here, none of the command has got IP in it. In EIGRP, in OSPF, all commands will have like show IP OSPF neighbor, show IP OSPF interfaces brief, show IP OSPF database. But that IP is missing because you know that OSPF is a IP layer protocol, network layer protocol. EIGRP is also a network layer protocol. But ISIS is a data link protocol. So no IP, the word IP. Simply show ISIS, show CLNS, show ISIS topology. Yep. You see the topology command? You have both CLNS topology, if you see the previous page, where it is to see that. Okay, you don't have, fine. Show ISIS topology. It will show you. Oh, yeah. I mean this one. Show ISIS database. Show ISIS topology. This will almost look like same, like topology will also have all destination. Database will also have all destination, but this is a link state database, which will have the advertised router, advertised network, etc. This will have including the cost. When we do the lab, we will see this difference. Okay, here is an example configuration intra area and inter area. You see, in router 1, which is only L1 router, you have only one database. Show ISIS topology, you have only one. But when you type show ISIS topology on router 2, which is both L1 and L2, you have two separate section table, one for L1, another for L2. Show CLNS protocol will display you like this. It shows its ISIS routing protocol, and this is the system ID. It's not showing area. This is area. Area is separately shown. System ID plus N selector. And this router is both L1 and L2. These are all the three interface where ISI is running, and it is IP version of ISIS. All right, and then both L1 and L2. Metric style wide is not configured, so it shows none. Show CLNS neighbor shows those routers that are neighbor. Right. See, serial is a point-to-point, so there is no need for a MAC address. But fast Ethernet is a broadcast environment, so it shows MAC address. MAC address is what we call as SNPA. Show CLNS interfaces, it will show all the interfaces, but when you particularly mention an interface, only that interface information will be displayed. And here we can see that the metric for L2 is set to 35. All right. And then the circuit, the router ID means the designated router is R2. Priority by default is 64. Neighbors system ID is R3. I'm seeing the information of my neighbor called R3 from R1. And this particular interface is L2. Okay. Hello packets are sent every 5 seconds. All right. So this chapter is about ISS configuration. Let's go and put some show commands in the lab that which we did previously. All right. We already have a lab. We have done the lab. Now we are going to put some show commands. Also, we'll change some metric and see. We have these routers all running from 1 to 5, which is enough. Let's first change the metric and see. Right now, when I type show CLNS interface F00, you can see that the default metric is 10 and the default priority is 64. We'll come to the priority after some time. Now let's focus on this. And also we see that the interface is both L1 and L2. Show ISIS neighbor R2, and it is forming only L1. But you saw that interface is both L1 and L2. Show run, if you see, globally we have made what? L1. That's why it is not having L2. Section. The previous lab, we did this. We globally said L only. So it cannot do both L1 and L2. Though interface level command shows you support of L1 and L2, but globally we have told not to do L2 adjacency. Right. Now let us go and change interface level L1 first. This is the command interface F0/0 ISIS circuit type. You see here level 1 finish. Now let us go back to that show command and verify. Show ISIS interface or show CLNS interface F00. You can see now it is only L1 circuit. Now let us go change the metric. Interface F00 ISIS metric. You see, I can give a big metric, but when I give 60, when I give 100, it won't accept. It says you should put this command metric style wide to have a bigger number greater than 63. You understand? But the problem is if you say metric style wide on one router, you have to do it on every router. Otherwise you will lose neighborship. Okay. So I'm going to set metric as 20 now. The default is 10. I've changed to 20. Let's go verify now. Show CLNS interface. See, it has changed to 20. All right, so we have verified this metric stuff. This IS type and all we did in the previous class. Today we tested the circuit type and the interface. We have tested that metric. You can also set metric level only for L2. For example, we have L2 on router 2 here. So I can say router ISS. I don't know what ISS processor I'm using. Show IP protocol. So the ISIS name I have. Okay, there's no name. So I'll say router ISS. And then I say metric style, IS type L2 only. No, what am I doing? I'm going to change the cost. No, I need to go to the interface. Interface F0/1 ISIS metric. And I'm going to say metric as 30. And it is for level 2 only. So it's only level 2. Anyway, this is going to have only L2 adjacency now. It is having L2 adjacency, not going to have it has got only L2 adjacency. Different area. Let us go and verify now on router to F01. We're typing the same command show CLNS interface F01. You can see here it is L1 with a metric of 10, but L2 metric is 30. So we have tested this also. Let's do the summarization stuff. Summarization. Now on R4, I'm going to add some networks. Show IP interface brief. Right now I have 444 only, but I'll do here interface loopback 1 IP address 4.4.1.1. interface loopback to IP address 4.4.2. 4.4.3. Done. We have these many networks of 4. And ISIs I'm going to run, so I say IP router ISIs. On loopback 3 it is done. Likewise on loopback 2. Likewise on loopback 1. These are the 3 interfaces I just added. Now if I go to router 2, show IP route ISIs, I can see many 4s. But I would like to summarize this. So go to router 3 and say router ISIs, summary address, summarize like this, all the 4s. And this I would like to do only for L2. R2 is L2 only, no? Level 2. So to R4 it won't summarize and send. Anyway, R4 is the source of the network. So I'm saying for L2 only. Now when you go back and check, earlier you were having all this, but now you should see only a summary of it. This will time out. You need to wait. This will time out. This will time out soon. Clear IP route. Start. I'm refreshing the routing table. Show IP route ISIs. Oh no, it's coming. I'm going back to router 3 again. I want to check why it's not suppressing. I said summarize like this. Between R2 and R3, what relationship? So ISIs neighbor. It's only L2. Why it is not doing it? Let me try putting this command on R4 itself. Maybe I should do it on R4 only. That's the source of the network. Router ISIs. Now on R2, I would like to go verify this. I'm surprised. Still seeing this. Am I missing something? No. Show IP route ISIs. Okay, I see something here. Suppressed. Okay, the assume it's not suppressed. Summary. I can see a summary route here, but show IP route. Yeah, because here also I summarized it, shows it, but it should not advertise the detailed route to R2. It's advertising. It's not related to metric. Anyway, R1 is not going to have this because R1 will have only a default route. Show IP route ISIS. R1 will have only default route to other areas. So the summarization is not for R1. It's only for R2. R2 should have a summary. Let's see the database. Show CLNS database or show CLS topology. Show ISIS database. Show ISIS database. This is R2, which is both L1 and L2. So you have a separate table for L1 and separate table for L2. Now let us type this command show ISIS topology. Here we see with the metric, and you see it uses only the MAC address. I also told you I would like to show you the multicast address that is used, layer 2 multicast address that is used to send hello. So I'm going to do Wireshark now for that. You see a lot of ISIS protocol traffic you can see here. When I select that, it says it's a ISIS hello, but when you go to the layer 2, look at this. This is the why. Okay, here it is, C2. This is a multicast address for all ISIs, L2. This is the same C2 and this is 14 and the previous one is 15. For L2 it is 15 ending with 15. That is how you need to identify ISIs. For L1 it will be 14. Yeah, 14. So you won't be having 5e in the middle. Earlier I said you will have 5e in the middle. That's a different topic, I think. Not for ISIs. 14 and 15 in the end. If you see in the MAC address that it is ISIS. So hello packet. These are the things that hello packet. So it carries the system ID. Right. So about the summarization thing, let me check again now. Show ISIS. I do see both this and this. I need to check why it is not suppressing the detailed route. I'll do a check later. I'll let you know. But according to what you have in the presentation, we have already done. Let's type show CLNS route and see the routing table. I will go to router 2, which is both L1 and L2. Show CLNS route. Nothing. Show It's okay. You know what this will show? Show ISI's route. Show ISI's route. Unfortunately, ISI is not running on OSI mode. Okay. Show ISI's topology we already saw. Anyway, these two commands are not for us. That CRS router, it's not showing. Let's see. Show CLNS. Show CLNS. It says that this particular router has got net ID so and so, belong to area 10. This is IP only mode, not OSI. Show CLNS protocol. Let's try. Show CLNS protocol. Okay, it shows all IP version of ISIS is running. Cool. Okay, like this, you can try all these commands when you do the lab.